This is one more application problem for the 89 calculator, and again, I'm not going to do any algebra because I've worked this out previously, algebraically. So you're going to make a coffee table with a glass top surrounded by a cherry border. The glass is 3 by 3, so here's my glass piece, which is 3 by 3. And you want a cherry border to be of uniform width, so going all the way around, this should be uniform width. So that means if this is x, etc., all those are uniform width. You have 7 square feet of cherry border, so all of this cherry border going around is 7 square feet. So I don't really care about the glass. And what should the width of the border be? So you do have to put together an equation, but then we can go to our calculator to solve this. Now when I worked this one out algebraically, I did several setup methods. I'm going to only do one on this, and it may or may not be the route that you would take, but we all get to the end result the same, of course. So I'm going to focus on this cherry border, and I can break it up into squares and rectangles. So each square, since this is x and this is x, the area of this square is going to be x squared. X times x, that's going to be x squared. X times x, that's going to be x squared. So the 4 corners are x squared. So I have 4 x squares, and then each of these rectangular pieces are going to be a 3 times an x, so 3x. 3 times x, 3 times x, 3 times x. So 1, 2, 3, 4 times 3x is 12 x's. And that all added together should have 7 square feet. Since it's a quadratic, get everything to one side, set it equal to 0. So to solve x, which is going to be my width of my border, I obviously want to find x-intercepts, the zeros, the solutions, blah, blah, blah. So I'm going to go to my calculator, go to my y equals, and type in that equation. So I have 4x squared plus 12x minus 7. Sorry, there's x there. Press enter. And start out with a standard window. So if I go to zoom standard, see what I can see. Now I know this is a positive quadratic, so it should be opening up. And I'm looking for the zeros, right? Well, here I see what I need to see. I can see both of my x-intercepts. X is a width, so I don't care about the negative one. So I'm actually going to go to my window, Diamond F2, and just change my x-min to like -2 because I don't care about that one. And my x-max, I had a lot of excess space, so I'm going to just change that to a 3 and just kind of graph it so I can hone in on that intercept there. Not that you have to do that, by the way. Okay, so now I'm going to go to F5 for calculate, and I'm going to choose 0 because I want to find that x-intercept. And remember, it's opening up, so to follow the path of that parabola, lower bound is actually below. Let's go a little bit below that x-intercept. Upper bound is above it, and it is at 0.5. Remember, that's essentially 0, so that means x equals 1/2 of a foot, so the width of my border should be 1/2 of a foot. And that's pretty slick. Granted, if you work this out algebraically, you know, you could use the quadratic formula or factor if possible, all those good options, but this was just as quick, I think.